guys, welcome back. I got bangs. So we're going to go over a lot of Calc 1 integrals to help you all practice. Also, I have some Calc 2 stuff at the end of this video just for fun. And by Calc 2 I mean integration by parts, which you go over in the beginning of Calc 2, which we're going to talk about next. Anyways, let's get started, okay? 24. So we have a U substitution problem here, and I just am going to put this one, assign this as my U, and see what happens, even though the derivative is not easily in there outside of the square root, if you know what I'm saying. So I'm just going to say U is x squared plus 1. We have du, which is 2x, and then 2x dx, and then let's just say x dx is going to be 1/2 du. Great. So this can be turned into, I'm going to do it down here, x squared, and then we have x squared plus 1 x dx. Now, we have everything in there. We have the u in there. We have the x dx, 1/2 du. Now we just have to plug in that x squared down there. And what are we going to do? We're going to rearrange this equation. So let's do it, okay? X squared is u minus 1. Just from simple algebra in our u equation, okay? So I'm going to move this a little bit out so I can fit that one in. So u minus 1 is going to be right here. Great. So this one is going to be something, I think we did this in our part 1 video. So I'm going to separate this into two integrals. First of all, FOH, we have that 1/2 out front, and I'm just going to forget about it until later. So we're going to distribute that u minus 1, and we get u to the 3/2. Do you see what I did there? I just kind of did the u to the 1 plus u to the 1/2. We got u to the 3/2. And then we have u, but that's going to be a minus u du. Okay, I'm going to zoom in a little bit. Okay, so I'm going to do these separately. Down here, we have u to the 3/2 du. That's going to be 2/5 u to the 5/2 plus c. Similarly, we have a minus u to the 1/2, which is going to be 2/3 u to the 3/2 plus c. That's going to be minus in the front. So let's do 1/2, and then we have 2/5. I'm going to plug in the u's, and I'm going to forget about the c's, but don't worry, I didn't actually forget about it. I'm just going to not put it in right now, okay? So u is x squared plus 1. That's to the 5/2. And then we have, that's a minus 2/3 x squared plus 1 to the 3/2. All right. I'm going to distribute this. We have 1/5 x squared plus 1 to the 5/2 minus 2/3 x squared plus 1 to the 3/2. Okay, and I think that's all we're gonna, oh, silly me, this has to be a 1 because we have to distribute the 1/2. So let's move on. Good job, friends. Okay, so this one we're gonna do, zooming in a little bit, we're gonna do u equals, guess. I'm talking to you, guess. What is u gonna be? Good. We're gonna do root t. The derivative is gonna be 1 over root t negative, because that's just a derivative. And if you have any questions about that, check out our videos on derivatives, okay? Okay. Okay, so let's plug her in. We have cosine of u over u dt. Oh, this one's not cute. Duh. We have cosine of u, and then we have, what am I doing? 1 over root t dt. This is gonna be there. And then plugging that in. Sorry for my horrid handwriting. We've gone over this, but I'm sorry. I try. So we get minus du. So the integral of negative cosine of u du is negative sine of u plus c. Plugging in that u, as we always do, we get minus sine of root t plus c. Minus sine of root t plus c. We have 26, right? 26, we have a classic integral. We're going to use the classic definition of an integral here. So an integral of x to the n is going to be x to the n plus 1 over n plus 1. And that's just a fact of the matter. If you don't like it, then I don't know what I'm going to say to you if you don't like it, but just know that you're probably wrong. So I'm going to do a u here because we can. So 3x minus 2. The du is going to be 3 because that's just a derivative, okay? And then dx is going to be 1/3 of du. So plugging that in, we get minus 1 of u, what am I doing? U to the 20th times 1/3 du. Taking out that 1/3 and then solving the integral, which is going to be u to the 21st over 21. Yeah, that's right. We're going to evaluate that at 1 and minus 1. All right, so I made a mistake. Don't hate me. Let me fix it. So first of all, we got the integral right, but what did we do wrong? We forgot to convert the original limitations to our u, right? So when so these are x's, right? When x is equal to 1, we have u being equal to 3 times 1 minus 2, which is 1. Okay, whatever. When x is equal to minus 1, we have a u is equal to minus 3 minus 2, which is minus 5. That's a little messy, right? So then these are our new limits. 1 to the 21st power is 1, obviously. 1/3 1 over 21 minus, let's figure out what minus 5 to the 21st power is. So minus 5 to the 21st. Okay, so that's just not cute. I'm just gonna put that like that. So the big idea here is, I'm not gonna solve this, but don't forget to do this part. But this is the right answer, period. Oh, this one's cute and easy. Let's do u is x squared plus 1. Du is 2x dx. Obviously, what am I doing here? This is a dx at the end. Who am I? Okay. And then an x dx is going to be 1/2 du. Okay. So I have 1 over u du, u squared, obviously. What am I doing? 1 over u squared. And then solving that, we get minus 1 over u cubed. U to the minus 2 is u to the minus 3 over 3. 3u cubed. Sorry. I'm not sorry. And that's our answer, plus c. Is that right? You tell me. I think it's right. Okay, so I had all of these problems filming. I'm new to this, I'm doing my best. So here's my old self without bangs, doing a couple problems, and I'll be back, okay? Hey guys, I'm back. 28. We are doing the integral of tangent cubed. So as we know, we have secant squared theta minus tangent squared theta equals 1. Rearranging, we get tangent squared equals equals secant squared theta minus 1. So we're plugging that in. We get the integral between minus pi over 6 and pi over 6. We get tangent theta times secant squared theta minus 1 d theta. We distribute this, and we get minus pi over 6 to pi over 6 tangent theta secant squared theta, and then we get minus d theta minus tangent theta d theta. So let's do these separately. Let's do some u substitution. Okay, I made a mistake, so now I have to fix it. We're doing these separately. I'm going to do this blue one first. U is equal to tangent theta du secant squared theta d theta. And directly subbing that u back in, this is horrible, my handwriting. We get 1/2 u squared. Now we have to figure out what the limits are here. So I'm going to do that. If theta is pi over 6, then u is going to be 1 over root 3. If theta is negative pi over 6, u is going to be negative 1 over root 3. Correct me if I'm wrong. So we're evaluating this integral at 1 over root 3 and negative 1 over root 3. And I get 1/2 1 over root 3 squared minus 1 over root 3 squared. And that's gonna cancel each other out, so that's 0. Right? I think I'm right. So next we're gonna do this one. Usually when we're doing the tangent integral, we're gonna have to do it in terms of sine and cosine, baby. So obviously we're gonna have to do it with this limit, these endpoints. I shouldn't be calling them limits because they're not limits, but endpoints. I'm just gonna do some more u substitution. And in order to figure out which u to choose, we just wanna do the derivative of whatever is on top, whatever can be factored out of the integral. Cosine, as u, since we know that the derivative of cosine is sine, and that can be factored out. So u is going to be cosine theta, du is going to be minus sine theta. U, as theta is pi over 6, u is going to be cosine of pi over 6, which is 1/2. Yes. And cosine of negative pi over 6 is going to be 1/2 as well. Whoa, that's pretty crazy, isn't it? So knowing that both of these endpoints end at the same value, so the endpoints are 1 single value. Both endpoints are 1/2. I already know this integral is going to be 0. So this is equal to 0. I'm still going to show you how to finish the integral, just so you know. So before we do that, we just know that this integral is 0, right? So if we finish this up, we get this. Sorry, I just copied and pasted that. Okay, so if we finish this up, I'm gonna get this to be du over u, because, oh, and negative, right? Because of this negative du, this final answer is going to be minus ln of u, which is minus ln of cosine theta. Okay. E to the 1 over x squared. Now, this is going to be a u substitution problem because we see something and we also see the derivative of that something in the problem. So let's do this really quickly, except for we have to do it in pink. When x is equal to 2, u is equal to 1/2. When x is equal to 1, u is equal to 1. Now, let's rewrite this. We have 1/2 and 1. We have a 1 over x squared dx. It's going to be minus du. And I'm going to put the minus on the outside. So we have e to the u du. E to the 1 over x, e to the u. And since the smaller number is going to be on top, the bigger number is on the bottom, let us take the negative of this integral. So since it's already negative, this is just going to be 1/2 e to the u du. You see? Because when you switch the top and the bottom, it's going to be the negative of that original integral. So let's just solve this. Anything e to the u is going to be e to the u, evaluated at 1 and 1/2. We get e to the first minus e to the 1/2, which is we have the integral from 0 to a of x times root x squared plus a squared dx. U is going to be usually what's inside something that's complicated. Du is going to be 2x dx. X dx is going to be 1/2 du. When x is equal to a, u is going to be 2x squared, because x squared plus, oh no, we get 2a squared. When x is equal to 0, we get a squared. Now, plugging all of this in, we get a squared, 2a squared. We get root u times 1/2 du. We get 1/2 the integral of root u is going to be 3/2 u, just kidding, 2/3 u to the 3/2, evaluated at 2a squared, a squared. I'm just gonna put the 2/3 on the outside. we get 1/3 is 1/2 times 2/3 is 1/3. And then we get 2a squared to the 3/2 minus a squared to the 3/2. We get 1/3. 2a squared to the 3/2 is going to be 2 to the 3/2. What is 2 to the 3/2? 2√2, I guess. But that's not really cute. And then a squared to the 3/2 is going to be a cubed minus a squared to the 3/2 is going to be a cubed as well. And then I get 1/3 a cubed 2√2 minus 1. I hope that's right. I think it's right. Again, I might make mistakes. Let's hope that it's not too bad though. Okay, here we go. So u substitution would be hard here because I don't see a derivative. I don't see the derivative of this in the problem. So although this doesn't look like although this problem doesn't look forwardly like we should be using u substitution, I'm going to try it because this is the derivative of this is 1. So then the derivative isn't going to be too crazy to compute. So let's just try it. U equals x minus 1. Du equals dx. And then x is going to be u plus 1. When x is equal to 2, u is equal to 1. X is equal to 1, u is equal to 0. Plugging all that in, distributing, and we get two separate integrals that are probably a little bit easier to do than this one. So let's do this one first in yellow. What is u times root u? It is just u to the 3/2. And that is going to be 2/5 u to the 5/2. And then that is just going to be equal to 2/5. Correct me if I'm wrong. And then similarly, this one is going to be u to the 1/2. And that is going to be 2/3 u to the 3/2. And that's going to be 2/3. Then we have 2/5. Then we have the 2/5 plus 2/3, which is the solution to both of these integrals. Oop. And what do we get? We get 6 plus 5. We get 11/15. Slay. 32. We're so close to being done. Not really. We're going to try u substitution first. I'm just going to try it. Why not? We get x just going to be u minus 1 times 1/2. When x is 4, we get u is 9. When x is 0, we get u is 1. All right. Let's see. Dx is going to be 1/2 du. And then x is going to be u minus 1 times 1/2. 1/4 in front of all of these. Remember, this is going to be 9 and 0. We have 9 and 0, and we have u over root u du minus 1 over root u du. And now, I think you know how to do this, but I'm going to do it right now really quickly, okay? By the way, these are ones, not zeros. I think that's right. We're going to do u substitution here, okay? So let's do u equals e to the z plus z. Du is going to be e to the z plus 1 dz. Plugging that in, we get 1 over u dz, or du. And then when we plug in z equals to 1, we get e to the 1 plus 1. We get e plus 1. We get, for u, we get for z equals 0, we get 1 plus 0, u equals to 1. So this is going to be e plus 1. This is going to be, not u, 1. The solution to this is ln of u. Plugging in e plus 1 and 1, we get ln of e plus 1 minus ln of 1. That is going to be the solution. 34. Okay, let's see how this goes. We're going to do u equals 2 pi of t over t minus alpha. Du is going to be this term. Dt. And then dt is going to be t minus alpha over 2 pi times, du. Okay, we get sine of u times t minus alpha over 2 pi du. Now, when t is equal to capital T over 2, we get 2 pi over t minus alpha times t over 2, which is not very cute. I don't like that. I think I'm just going to ignore that for now. So let's just do it. We know that this is something and this is something. And then this part we can pull out and we get t minus alpha over 2 pi. What is the integral of sine u du? It's going to be minus cosine of u evaluated at something. Now, when we have situations like this where we don't want to plug in these gross numbers, even though 0 is not that gross, but I don't like that top number. So I'm just going to plug back the u, the original u. So we get t minus alpha over 2 pi and then we get minus cosine of 2 pi t over t minus alpha. And that's going to be evaluated at t over 2 and 0. And so I'm just going to write this ugly, ugly problem. I don't know why it's here, but it's here, and so we're going to do it. And we get minus cosine of 2 pi t over 2 times t minus alpha. At least the 2's cancel out. We get something like that, and we do minus. We have a minus cosine of 0 in there. Cosine of 0 is 1, minus cosine of 0 is minus 1. We have that minus here, and that's going to be 1. Final answer is going to be t minus alpha over 2 pi times minus cosine of pi t over t minus alpha plus 1. Gross. Okay, moving on. Yay, we have indefinite integrals. So that means we have that plus c, period. So this one, I'm going to try and get somewhere with this. So let's do... I should try and have my handwriting look a little bit cuter. X squared, we get x squared minus 2x plus 1 all over x squared. And then with that we get 1 minus 2 over x plus 1 over x squared. Oh. We can do this. We get 1 dx minus 2 over x dx plus 1 over x squared dx. This is going to be x plus c, some c, minus 2 over x is going to be 2 times ln of x plus some c2. And then we have 1 over x squared, which is going to be minus 1 over x plus some c3. Then that's our final answer. We get x minus 2 ln of x minus 1 over x plus, sorry, some big C. And this is a different C than all the other ones. And I'm not here to tell you what that C is all about, but we just have to put it down and see what happens. Anyways, okay, now looking at my trusty thing over here, the derivative of minus cotangent x is going to be cosecant squared x. Using that, we get u being that 1 plus cotangent x on the bottom. Du is going to be, that's going to be 0. Cotangent x is going to be minus cosecant squared x dx. Plugging all of that in, we get minus du over u, which is going to be minus ln of x, ln of u, excuse me, and we do minus ln of 1 plus cotangent x, period. Okay. Now, I wrote this down, this green little formula down earlier because I wanted to remind myself that integration by parts is a thing. And I think that this is first taught in calculus 2. However, right now we're going to go over it and we're going to do at least a couple problems. And this is the trusty formula that for some reason I never could get it in my head, so I always just kind of like write it down somewhere. And you know, that's okay. That's okay if you can't memorize things. It's all about the knowledge, not the memorization, and the intuition behind why you do certain things in math. So we have this thing called Lie8. And I think it's logs, inverse trig, we have algebraic, we have trig, and we have exponential. I am, again, so sorry for my horrible handwriting, but this is what happens when you're a chaotic person, and that's fine. It's okay. So using that, we have logs, inverse trig, algebraic, trig, and exponential. So this is the order in which you choose the u in the inverse trig, or in the integration by parts. So do we have a logarithm function? Nar. Do we have an inverse trig function? Nar. Do we have an algebraic function? Sorry. Yes, we do. So let's do that. We have u as x, and then we have that dv as cosine 5x. du is going to be 1 sleigh. And then we have v, which is going to be 1/5 sine 5x. By the way, this is going to be a dx there. This is that dv. This is that u. And when we plug in this formula of integration by parts, we get u times v is going to be x times 1/5 sine of 5x cubed minus v du. And so we get minus 1/5 sine of 5x dx. Now, What is the integral of 1/5 sine 5x dx? Thanks so much for asking. The integral of this thing is going to be, let's just pull out the 1/5, and then we're doing the sine 5x dx. Taking the antiderivative here, I get 1/5 minus cosine, so that's going to be cosine 5x, and then I would take the chain rule antiderivative and get 1/5. So then altogether we get 1/25. So this would be the final answer. 38. I'm gonna do some U substitution, I think, because I think that's gonna make this life a little bit easier, but I could be wrong. Plugging all that in. This is going to be 1/u times 1/2, which is 1/2u plus c. Plugging it into the original variable x, we get 1/2 times 2x plus 1 plus c cubed. Okay, now we have another silly integration by parts. So again, when I see something like this, I'm going to put u dv, which is uv minus v du. Is there log? No. Is there inverse trig? Nar. Is there algebraic? Yarsh. I'm sorry, I'm doing this thing where I say R to everything, like nar. When you say no, you just say nar instead, because I feel like it conveys more emotion, and I don't know. Anyways, u is going to be x squared plus 1. dv is going to be e to the minus x dx. v is going to be minus e to the minus x. And then du is going to be 2x. For now, I'm just going to solve the indefinite integral because that's going to make things easier. So x squared plus 1. I'm going to deal with that at the end with the 1 and the 0, the definite part of the integral. uv is going to be x squared plus 1 times minus e to the minus x minus v du. And so we get e to the, I'm just going to make this a plus and get rid of that minus here. Okay, so we get e to the minus x. du is going to be times 2x. And would you look at that, we have another integration by parts. Lord have mercy, I don't know what to do here except for we're going to do it again. Because the green u's are going to be different than the pink u's because we're dealing with a different problem here. So then we get dv, which is going to be e to the minus x. We get v to the equals e. I'm going to rewrite this out. And we're going to write out our new problem. So uv is going to be 2x times minus e to the minus x. I'm going to rewrite this. We have 2x times minus e to the minus x minus v du, which is going to be plus this e to the minus x du times 2. This is going to be dx, by the way. And this is going to be equal to 2 minus e to the minus x. Okay. And we're going to evaluate all of that at 1 and 0. Plugging in 1 here, we get 1 plus 1, 2 times minus e to the minus 1, which is going to be 2 over e. And that negative is going to be out front, because e to the minus 1 is 1 over e. And we've got 2 minus, okay, so minus 2 plus e, or minus 2 over e, plus 2 times minus that 2 is up there, that minus is in the front, and then we get e right there as well. Plus, we're going to have the same thing here, I guess, minus 2 over e. So that's just for the 1. Let's plug in the 0. We get 0 plus 1 equals minus e to the 0, which is going to be minus 1. We get 0 in the second term, and we get e to the 0, or minus e to the 0 is going to be minus 1 times 2, which is going to be minus 2. And we get minus 2 over e, minus 2 over e, minus 2 over e. What is that? That's minus 6 over e. Minus 3, which is going to be plus 3. And that's our final freaking answer. And we went through hell to get there, but I liked it and I had fun, you know? All right. Hello again. We have some more problems right now, so let's do 42. The integral of x times ln of 1 plus x dx. The Lie-8s that we talked about, we have logarithms, so that's what I'm going to do first. As the u, I'm going to assign the logarithm as the u. So we have u equals log of 1 plus x. Du is going to be 1 over 1 plus x. There's no chain rule there because we're perfect. So dv is going to be x, and then v we're going to find to be 1/2 x squared. So, let's do it. So I'm going to plug it in. We have uv, which is going to be 1/2 x squared times log of 1 plus x. We're going to subtract a 1/2 x squared over 1 plus x. Okay. So over here, use substitution. I'm going to do 1 plus x du equals dx. X squared is going to be u minus 1 squared. Oops, sorry. So let's try that. We have u minus 1 squared over u. We get times du. Okay, so I'm going to do u squared minus u plus 1 all over u. So I'm going to separate all of them. We get u, du, obviously, this du should be there. And then we get minus u over u is going to be 1 du plus 1 over u du. We're going to forget about the plus c's right now, but just know that at the end it's going to be plus c. So this is going to be 1/2 u squared plus u plus log of u. Plugging in the u, I get 1/2 1 plus x squared plus 1 plus x plus log of 1 plus x. Okay, that was kind of unsexy, but we're gonna continue and just get our answer down. So we have 1/2 x squared log of 1 plus x. And then we have minus 1/2 of 1/2 1 plus x squared plus 1 plus x plus log of 1 plus x. I'm just writing over things as if they don't exist, okay? So that's our answer. All right, 43. So this is some trig substitution. And here are the rules for trig substitution. I know we're gonna have a video on that coming soon, so I'm gonna put the rules here so you know. So tan to the 5th, secant to the 7th. So what I'm gonna do is I'm gonna pull out a tan secant because there's an odd secant. And then we get tan theta secant theta. What are we missing? D theta. Great. So this, we have some u substitution we're going to do. This is a derivative. It's the derivative of secant. Let's turn the tangent into something that looks secant-like. And we do that by looking at our cute little identities here, because things are secant squared minus tangent squared equals 1. Thus, tangent squared, secant squared minus tangent squared equals 1. So then tangent squared is going to be secant squared minus 1. So we have secant squared minus 1 squared, secant to the 6th, and then we have tan theta, secant theta, d theta. U substitution du is going to be, what am I doing? It's not secant, it's squared, it's secant theta tangent theta, d theta. So we get something like u squared minus 1 squared u to the 6th, and then du. We're just gonna have to do a bunch of algebra, which I'm gonna do real quick on the side. Okay, see what I did there? Let's finish this up. And I'm just going to skip the step of actually doing the integral and plugging in the u, so I'm just going to plug in the u right away. So we get, okay, so we got secant to the 11th theta over 11 minus 2 over 9 secant to the 9th theta plus secant to the 7th theta over 7 plus c. Lord have mercy. I hope that's right. If it's not, then I'm going to refilm this and who cares. Okay. Let's do another one. This one, instead, we're going to pull out a secant squared because tangent is even. Okay. So tangent to the 6th x, and then we have secant squared x, and then we have secant squared x dx. So that tangent is going to stay here and it's going to be happy. We have secant squared is going to be 1 plus tangent squared. Okay, so this one I'm not going to use the u substitution because quite frankly, I don't want to. So we get tangent to the 6x dx plus and using that chain rule situation going on, there's going to be a secant squared x. Using that chain rule situation, I'm skipping a couple steps here, and I get tangent to the 7th x over 7 plus tangent to the 9th x over 9. And that's just from the simple rules of integration. So, and we are able to do that because the derivative is already inside of it because of that u substitution. Does that make sense? So don't forget the plus c. All right, so when I wrote these problems, I put this little formula because I knew I would forget it. And of course, it's on my little sheet that I always have. Duh. So let's do it. So obviously 4x is going to be that theta, and then I think that's phi. That's going to be 5x. So I'm just going to do some simple algebra to convert this, right? So sine of 4x plus 5x is 9x plus, I don't need these parentheses here, plus sine of 4x minus 5x. We get sine of minus x all over 2. I'm going to turn this into two integrals. I'm going to ignore the 1/2 for now. So we get sine of 9x plus dx, obviously. Sine of minus x dx. So since the derivative isn't inside, I'm just going to do a quick u substitution for each of these. So we have u is 9x, du is going to be 9, dx is going to be 1/9 du. So plugging that in, we have sine of u times 1/9 du. And that is going to be 1/9 times minus cosine of plugging in that u. I know I'm going fast, but I think that at this point you could already do this by yourself if you've gotten this far. If you have gotten this far. Let's do the other one. We have u equals minus x. Du is going to be minus dx. Minus du is going to be dx. Plugging that in, we get, this is going to be that 1/2 times that whole thing. I'm going to get sine of u. Now for this one, the minus, it's kind of not necessary to do all this, but I'm just doing it. And that's going to be a minus, so that's just going to be a cosine of minus x. And that's all. So finishing up here, I'm going to get that 1/2 times 1/9 of minus cosine of 9x plus cosine of minus x plus c. So similarly, I'm going to rewrite this. I'm going to get cosine of 3x minus 6x, and we get minus 3x minus cosine of these two added. We get 9x all over that 2. Ignoring that 2 until later, I'm going to separate these. We get cosine of minus 3x minus, we have a cosine of 9x dx. I'm going to do these separately, although I'm going to see if I can skip the u substitution here and just do it. So I'm going to do it separately just in case. So we have sine of minus 3x times 1/3 times negative 1/3. That should be right. And then we have, this one's going to be sine of 9x times 1/9. That should also be right. Obviously, I'm going to check this later. Okay, so then we are going to bring in that 1/2 and that negative, and I'm going to write the final answer here. So we have we have the minus 1/6 sine of minus 3x minus 1/9 sine of 9x. And that concludes number 46. We have 4 more left. All right, last scene change. We have 4 more problems left, and we're gonna do it. Yeah, 47. Tangent to the 5th dt. So we're gonna find that integral. We're gonna remember that tan squared of t equals secant squared of t minus 1. We're gonna rearrange. We get tan to the 4th t tangent t dt. It's okay that we don't see a secant there. I know our goal is to get a secant tangent or a secant squared. We have the tangent and we'll just call it a day. So then that can turn into secant squared of t minus 1 times tangent t dt. Great. So now we're going to apply the u substitution. I'm just going to do secant t to make it easy. So du is secant t tangent t dt. We have the tangent t dt, and that is good enough because we're just trying to get rid of the dt here, or the dt here. So we get tangent t dt equals du over secant t. And now let's plug her in, period. So we got u squared minus 1, and we get times du over, that secant t is a u, right? Then we are going to pull those apart because we can, and it'll make it easier. So I'm going to do that really quickly. Boom. So that's what we get. And then I'm just going to plug in the u again. 1/2 secant squared t minus log of secant t plus c. Slay. Okay. When in doubt, when it comes to trig substitution, you just want to be able to get rid of the things that bother you the most. So the thing that is bothering me right now is this sign on the bottom. And so I'm going to just see what happens here when I just do a u substitution, right? So most likely it'll work, especially in Calc 1. So that becomes cosine to the 4th alpha. We're going to have to figure that out later. And then we get cosine alpha d alpha. And then we have, that's d theta. And then we have the square root of sine theta, or sine alpha. What the heck is going on? Now we are in a good position here. So sine squared plus cosine squared equals 1. Cosine squared equals 1 minus sine squared. I'm going to plug that in. Actually, we're going to do this work right here. So cosine to the 4th alpha, we're going to try and get it in the u notation, or the u variable. We're trying to get rid of the alpha here. So that's going to be 1 minus sine squared alpha squared. Then we get 1 minus u squared squared. Slay. So we get what we needed here. And we get 1 minus u squared squared all over root u du. Again, I'm so sorry for my handwriting. I need to be better. So we're gonna do it, okay? I am going to just do some algebra with this and see what happens, and I'm gonna speed it up right now. Period. Okay. So next we're gonna do several u substitutions here. So I'm just gonna get the pi x out of here because it's kind of making things ugly. So I'm just gonna substitute another variable in. So, rewritten, that's going to be 1 over pi times sine squared v cosine to the 5th v dv. You see what I did there? So now this is an easier and cuter problem. So we're going to do similar things here. So cosine is an odd number, so we're gonna pull the cosine out. And we are going to do another u substitution here. We're gonna do sine because that cosine is by itself here. And the derivative of cosine is going to be sine, and the derivative of sine is going to be cosine. So, what am I doing? So we got the u substitution all figured out. We get 1 pi. This is going to be du. The sine is going to be u squared. I have to figure out what this cosine to the 4th of v is going to be in terms of u. So that's going to be 1 minus sine squared v to the 2nd power. So then that is going to be 1 minus u squared squared. And then that, because I know we're going to have to distribute it at some point, we're going to just prep for that right now. Boom. Now we have to substitute until we get back to the original variable, which is the x. We know that u is sine of v, so let's get that u out of the way. Then we have v is pi of x, so I'm just going to plug that in. Here we get 1 over 7 pi sine to the 7th of pi x minus 2 over 5 pi sine 7th of pi x. That's not 7, that's 5. Plus 1 over 3 pi sine to the 3rd of pi x plus c, period. Cosine is secant, so I'm going to make that substitution. And then we are going to rewrite tangent cubed x over secant squared x dx. So I made that substitution, and I'm going to rewrite it here, and I just did that. And then we are going to make some substitutions, I guess. What did I do here? I think that I took out that tangent because the tangent's odd. So I turned the tangent squared into a secant squared minus 1. So we are going to rewrite this here. We got secant squared x minus 1, tangent x all over secant squared x. U substitution we do. So you see what I did there? I just moved the secant x to the other side, and since secant x is u, we moved that here by dividing it. Since secant is u, we just put the u down here. Let's move on. We get secant squared x minus 1 over secant squared x. What am I doing? So we get u squared over u squared. U squared minus 1 over u squared minus du over u. That is going to be u2 over u3 du, and that is going to be 1 over u3 du. That's going to be minus. So this, we are going to cancel the u. For this one, we're going to cancel the u squared, and we're just going to get 1 over u, which is going to be log of u. For this one, we are going to get 1 over u squared times 1 over minus 2 plus c. Rewriting that in pink, obviously, we're going to get ln of secant x plus 1 over 2 secant squared x plus c, period. And we're done. We have completed all 50 integrals. Please like and subscribe. Send us your homework or your questions on Instagram, and we will answer them. All of the links are below and always available for tutoring at math-savvy.com.